Hello everyone, hope you all are safe and staying at home. We are focusing on our concrete technology subject. In that, we are starting with module 4 and subtopic creep of concrete. In this creep of concrete, we are focusing on the following points: introduction, creep definition, creep concept, microscopic rheological approach, factor affecting on creep, effect of creep. We start with the introduction and definition of the creep. Creep is simply defined as the time-dependent part of strain resulting from stress. Creep can also be defined as increase in strain under sustained stress. Creep occurs when there is a gradual increase in strain without increase in stress. Means strain increases in the material at constant stress, and this increase in strain is time dependent. To understand the creep concept, here one example is provided to you. This is a spring. One end of spring is fixed at the floor and another end is free. In the second figure, this spring is loaded. The load is placed at this point A. So we'll see the creep concept from these figures. In the first figure, there is a no load on the spring. In second figure, we place the load at point A. As soon as we place the load at point A, the spring deformation takes place instantaneously. Means as soon as I put the load, there will be instant deformation in the spring. If we keep this load as it is for a long time, the deformations of spring continues, and this deformation increases gradually, that is delta 2. So this increase in deformation for a longer duration is at a constant rate, and this is not an instantaneous deformation. If I again keep this load as it is for long time, so again spring deformation takes place, but that deformation is at a slow rate. So here we can understand that as the time passes, spring deformation takes place slowly. After more passage of time, spring deformation takes place at very slow rate. Means in this figure we can make one concluding statement that strain is a function of time. As the time passes, there is a development in the strain. In this case, stress is constant because we are keeping this load constant, and there is no change in the cross-sectional area of the spring. Hence, stress is constant, but there is an increase in strain with respect to time. So we'll focus on this creep curve of the spring. So when we are plotting the creep curve, as creep is a function of strain and time, so we have to plot this graph strain versus time. Here you can see in this graph, when we correlate this graph and this figure together. At instant when we place the load, due to this load, there is an instantaneous strain. Means instantaneous deformation occurs. At a smaller, within a short span of the time, the deformation of spring is more. Hence it is called as instantaneous deformation. So there is no time but instantaneous strain. And we keep this load for a long time. So this creep is gradual for certain, creep is linear for certain time. Means strain is increasing with respect to time. That zone is called as primary zone. Later, as the time passes, strain rate is slow down. You can see here from this point to this point, the strain amount, increase in strain amount is less, but it took more time. So that is the secondary part. In the next zone, that is called as tertiary zone, where there is a gradual increase in strain for a shorter time. In this zone, the stress in the spring is more than the permissible stress in spring. Hence, spring get ruptured, and when the rupture position is taking place, there is some increase in strain observed at the end of the rupture stage. So this graph gives us idea what we have discussed with this figure. So there are three zones: primary, secondary, tertiary. This indicates the slope of the creep, so which is helpful for calculating the creep deformation in the concrete material or in any material. So we elaborate these stages: primary stage, secondary stage and tertiary stage. Strain rate is high and gradually become less. So in the primary stage, strain rate is high and gradually it is less. That means from this point to this point, the strain rate is high, and from here it is gradually become less. In secondary stage, creep strain occur at constant rate. So this is the stage where creep occurs at the constant rate. Tertiary stage, creep strain increases and lead to rupture. So here it is shown that creep strain is increased and leads to the rupture finally.